Yeah. What do you mean by angle of incidence?
Angle of incidence happens with a normal ray.
Couldn't get, come again, please.
It is when an incident with the normal ray.
Hmm. Incident ray,
When an angle is made by
angle
the
made by the incident ray with the normal
normal ray.
is called as angle of incidence, right? Then, Mona, can you tell what is reflected ray, angle of reflection?
Yes, ma'am. Angle made by reflected ray with normal.
Angle made by reflected ray with the normal is called as angle of reflection. Then, Pathikrit, can you tell the laws of reflection? First law,
The ang- the angle of incidence is equal to the angle of reflection.
angle of incidence is always equal to angle of reflection, okay? And second one,
The incident ray, normal, and the reflected ray are all in the same plane.
always lie in the same plane, right? Now, next we have to learn the types of reflection. I have explained you the types of reflection, regular reflection and diffused reflection. So, regular reflection means the type of reflection in which incident rays, the parallel incident rays, after reflection through the surface goes parallelly. If the incident rays are parallel and after reflection also the reflected rays remain parallel, this will happen when the light ray strikes the smooth polished surface, plain smooth polished surface, then only the incident rays, parallel incident rays, after reflection they remain parallel. Then this type of a reflection we call as regular reflection. And then the irregular or diffuse reflection diagram itself tells us incident rays are parallel to parallel incident rays when strikes the surface. Due to irregular surface, uneven surface, the reflected rays could not remain parallel. Then such reflection is called as diffused or irregular reflection. So you have to write this definition in terms of this one only I will give you as a comparison, differentiating points. So regular reflection, the parallel, right along with me, parallel incident rays remain parallel after reflection. And here when incident rays, parallel incident rays, sorry, when parallel incident rays strike the surface, could not reflect parallel to each other. This happens when surface is smooth, plain and polished. This happens when surface is rough, irregular.
I'm done.
Okay. Now we have to see the image formation by plane mirror. Is it clear now? Regular and irregular reflection.
Yes, mom.
Now next is image formation by plane mirror. So what is plane mirror means? Plane mirror whose surface is completely smooth, that is whatever the mirror you see in your in our house for makeup purpose, for shaving purpose, whatever the mirrors we see, those are all plane mirrors where the path is completely surface is smooth, polished. It is a smooth polished surface, uh, silvered from the backside. And one thing, that is a face is completely plain. This is completely plain surface, like this way it is plain. If you curve it, if you see that's this way, it is not this way, it is not curved, it is completely plain like this. There are mirrors or of plain mirrors, this way bent also, this way bent or this way bent, anything is possible. These are not bent. So whenever it is a surface is exactly perpendicular, if you keep anything in bottom, if it is completely perpendicular, then this is called as plane mirror. Straight, perpendicular, straight figures are there. So those are the plane mirrors. So plane mirrors, we show the plane mirror when we have to show the ray diagrams. That means when ray strikes the mirror and then how it get reflected. To show those, the rays, the number of rays falling on the mirror and then it is reflecting back. To show all those things, we have to draw the figures. Those we call as ray diagrams. For drawing ray diagrams, we have to, there are some no this side faces of the mirrors we have to show. Plane mirror. So plane mirror, if it is a horizontal we are keeping, so we have to place like this. This is a one straight line which shows the plane mirror. Here the front face is the reflecting surface. This area is a reflecting surface. That means through which the reflection takes place. A reflecting surface. And this part, backside part, we have to show with this slant rays. Slant dashes we are showing. This shows that backside is silvered. That means we have to keep a paint over that. Painting has been done backwards. Backside the painting has been done. So front panel will become this silvered. Means it is seen to be reflecting surface will be seen from this edge. If you want to show this in vertical, then it will be like this. We have to show like this. So this face is reflecting face. And this is silvered. Means here painted. This part area from the back side, it has to be painted. So we have to show like this. Now we have to show the image formation by the plane mirror. How the image will be formed in the plane mirror. For that, we will take, this is a plane mirror. This end is silvered like this. We have to place a object here. Suppose object is at this position. This is object, point object A. Okay. Now from this, whenever to form the image, that means when you, image means what here? When you are standing in front of the mirror, you will see your lookalike inside the mirror, right?
Yes.
Where anything in front of you or in front of the mirror, anything you place in front of the mirror, that will become object. And whichever the lookalike of that object we see inside the mirror, so that lookalike of the object which we see, that is called as mirror, sorry, image. So object and image, is the difference clear? Object means which is you are placing in front of the mirror, any object, anything. When you place in front of the mirror, that is the object. And image is that object's lookalike is formed inside the mirror. Then that is called as image. Clear? Is it clear? When you are standing in front of the mirror, you will be the object. When you are in front of the mirror, you will be the object, and your image lookalike will be seen inside the mirror. Then that is image. So we have to check out how the image will be formed. So how to draw the ray diagram for image formation. For that, important thing is minimum two incident rays. We have to draw that incident to the mirror. Minimum two incident rays from that object should strike the surface and they get reflected. Two rays from point A we have to draw on the mirror, means they will fall on the mirror. After that they get reflected. Then where the image of that point A is formed, for that thing, the two reflected rays should intersect somewhere. They have to meet somewhere. So wherever those two rays, reflected rays meet, there the image of this point A is formed. So two rays need to fall on the, should strike the surface. I will take one as this one. This is one incident ray. At this point, we have to draw normal. To draw the reflected ray, I is equal to angle I is equal to angle R. For that, we have to draw perpendicular. Okay, so this is a normal. This is incident ray. Then angle between them is angle I, angle of incidence. This we have to measure. Equal angle, we have to make other side of this normal, but it should be equal angle. So this is, suppose it is 30 degree, you got it. Then you have to make 30 degree on this side. And you have to draw the ray like this. This one. So this is also R. I and R are equal. Okay. Now another ray I will take this way. It falls at this position. Okay. Now at this point I need to draw perpendicular, normal to the surface, normal ray. So this is angle I. Now equal angle has to be made like this way, is the second ray, by making equal angle R. Now here you can see this is going here. If I will produce it forward and I'm producing this forward, is it possible they will meet on this side? Is it possible they will meet, we produce infinitely on this side? No, they can't produce because they are diverging from each other. They are moving away from each other. So they can't meet. So for that thing, what we have to do is we have to make them meet. So in such case, what we have to do is we have to produce them on other direction. Other side we have to produce them. So we have to bend them backwards, produce them backwards. And here also, this is also, I need to produce it like this. So it should be a straight line. So they meet at this position. Here at this position, they will meet. So this is the image of A that I will give the name as A dash. Clear? Is it clear? It's not so much proper. Okay, they will meet at this position. So this is image of A, which is A dash, which is exactly on the same line of A. If we join A and A dash, they will be exactly on the same straight line. This distance is equal to this distance. From the mirror to A distance, mirror to A dash distance will be always equal. You have seen in your case also, when you are standing in front of the mirror, how much ever distance you are in front of the mirror, equal distance, the image will be behind the mirror. If you move certain distance forward, what will happen?
And the
If
image will
you
get closer.
image will also come closer to the mirror. So if this is you and this is a mirror, whatever the distance you are in front of the mirror, the same distance is object is in image is also inside the mirror. Clear? Then it always form inside the mirror. For the plane mirror, image is always formed inside the mirror, right? So inside the mirror, that is the word. In physics, we call that as behind the mirror. The image is formed behind the mirror. Okay, behind means there is nothing behind the mirror. Okay, we cannot place anything to get it. It is always formed inside the mirror. That is the word scientifically we use the word as behind the mirror. Okay, now so first draw this, then we will discuss about the characteristics. So for discussing characteristics, you need to know some definitions. So draw this, first draw this one, give the heading as image formation by plane mirror. Draw this with scale and pencil. Completed?
ma'am, should we draw the diagram of the?
No. Second. No, only one. Here, this is what I've done. The same thing is here, only the vertical. Mirror is vertical.
Okay, ma'am.
This is a candle is the object. From that, two rays falls on the mirror. They get reflected like this. So they can't meet here. So we have to produce them backwards. So wherever it meets, there is the image of this flame of the candle will be formed. So this is, we are seeing only one point image. Like that, millions of rays will move from this candle, and they all may they intersect at this position. So every position, the image of this exactly that object will be formed here. So we are not supposed to show every point's image. We are only showing the upper point. Only the flames as image we have shown. Like this, it will form. Clear? Now we have to see the characteristics of the image. How the image is formed, that we have to see. So image is formed inside the mirror, that is behind the mirror. At this place, is it possible to place a screen? Screen means anything like a white paper, white screen, white wall. If it is a wall, can be white cloth can be considered. Can we place here and measure the dimensions directly, physically touching them? Is it possible? Is it possible that is you are standing in front of the mirror and your image is formed behind this one on the screen, can be taken on the screen? Screen means anything, white sheet, white paper, anything can be considered as a screen. Is it possible?
Ma'am, like projectors.
Projectors, yeah. Is it possible that is we will obtain our own image on that screen if we are standing in front of the mirror? Yes or no? Is it possible? We can keep the screen inside. Suppose a thin paper, a big paper, we keep it there and we can get our image on that. Is it possible or not?
Ma'am,
Couldn't get yes or no.
yes, ma'am.
Possible, we can place there.
Yes.
So you can place this one. Any paper you can place inside the mirror. Inside the mirror, you can keep any paper, right?
Ma'am, we can show the reflection on the mirror.
No, reflection on the mirror only. But is it possible that is we can place the paper inside the mirror and the image will be formed on the mirror? Possible?
No, mom.
No, ma'am.
No, not possible. Let's see one example. Are you able to see this picture?
Yes, mom.
What is here? Here is one mirror. This is not plain mirror, different mirror. It is spherical mirror. Here is a candle. And the flame of the candle is obtained here. Right? This is a white sheet is placed. This is a white sheet has been placed in front of the mirror. And here we are able to obtain this image of the flame. This flame is obtained here. Lookalike of this flame is obtained on the paper. This is called obtaining on the screen. Obtaining image on the screen. This is called formation of the image on the screen. Is this condition possible in case of plane mirror? Is this case possible in plane mirror?
No, ma'am.
No.
No, we cannot place anything inside the mirror. We can't go inside the mirror. That is a virtual imaginary case is formed. So therefore image cannot be formed inside this image is formed inside the mirror, but the screen cannot be placed inside the mirror. Now here you can see this image is formed on this mirror, inside this mirror. That is it possible to go inside the mirror and place a paper and there we will get the image? No, that won't happen. So this image is called as virtual image. Virtual, that is imaginary. And this image which is formed on the screen is called as a real image. Clear? The image which we obtain on the screen, on the projectors, those are called as real images. And the images which can be seen inside the mirror, to see that image we have to see inside the mirror. We cannot see here and there somewhere. If you are in front of the mirror, then only you are able to see your image. If you are away from the mirror, are you able to see?
No, mom.
No, you can't see. That means to see the image, you have to look through the mirror. So those are imaginary images. So therefore, those are called as virtual images. And the images which are formed on the screen, those are called as real images. So images are of two types, real images and virtual images. So real images are those images which can be formed on the screen, and virtual images which cannot be formed on the screen. And to get the real image, to obtain a real image, this reflected rays will meet in front of the mirror. To obtain any real image, the reflected rays will meet, that is, they intersect in front of the mirror. They will intersect in front of the mirror. That will happen in case of mirror, spherical mirrors. In spherical mirrors, the reflected rays will meet in front of the mirror. This is it, I will show you. How they meet. If you consider this is a spherical mirror. Spherical, that means it is not plane. This part, reflecting surface is curved. This is called spherical mirror. This is concave mirror. When the rays from that object falls on the mirror, after reflection, they will intersect at one position. And this point of intersection is in front of the mirror. We are not supposed to produce them backwards. After reflection, they all intersect at one position. And here is the image. At that position, the image will be formed. So here, this reflected rays will intersect in front of the mirror. Then the image formed is a real image. But in case of the plane mirror, the reflected rays can't intersect in front of the mirror. We have to produce them backwards. Inside the mirror only they intersect. So there, this is possible, or this is happen only in case of virtual image. So virtual image, the reflected rays meet only when they are produced backwards. Reflected rays will meet only when they produce backwards. But the real images are those images in which the reflected rays, all these reflected rays will meet in front of the mirror. Able to understand this point? Second point of difference between real and virtual images. Able to understand?
Yes, mom.
So what is real and virtual images difference? Real image, virtual image. Image which can be obtained on screen. Write along with me. Image which cannot be formed or obtained on screen. Second point of difference is the reflected rays. Reflected rays meet in front of mirror. Here reflected rays will meet only when produced backwards. And the third point difference is real images are always inverted. Virtual images are always erect. Done?
Yes, ma'am.
What is the meaning of last point? Real images are always inverted and virtual images are always erect.
Ma'am, real images are upside down.
Upside down, yes. You can see the image of tree. This is a real image. You can see that this tree is upside down. Actually, tree is the same. It is the rays from the distant tree. Tree will be the same position, that is the stem at down. Bark is at the bark will be the stem, bark will be the down, and the top is the leaves. The same object will be there, but the image is formed. The root stems are upward and the leaves are downwards. So this is the upside down. This is called inverted image. Even in case of this candle also, you will see the flame is upward here, but here it is downwards. So this is called inverted images. And the real images are always inverted images. And this one, the virtual images. The virtual images, just like your image in the plane mirror, will it be upside down or as it is? Do you see upside down image of yours in when you see through the mirror?
No, ma'am.
No, you see as it is image, that is called as upright image or erect image. So that is called as erect image. So virtual images are always erect. Just like here you will see candle is standing here, flame is at the top, wax is down. Same thing, image also you will get it candle flame at the top and the waxes down. So the same image, this is called as upright or erect image. Clear? And this is inverted image. So real images are always inverted and virtual images are always erect images. Clear? Difference between a virtual image and real image is always asked. So you should remember these 3 points. Now, by knowing this, we have to learn the properties or characteristics of the image formed by plane mirror. So what are the things you will observe when you see your image inside the mirror? So first thing is its nature, whether it is a virtual or real image. Image is virtual or real?
Ma'am, virtual.
Virtual image because it is formed inside the mirror. So it is virtual image. Characteristics of images formed by plane mirror. So first one is nature. It is virtual and erect. Virtual images are always erect images. So virtual and erect. Second thing is size. How you see the size, whether it is of a same size, enlarged or smaller sized. How you'll see your image?
Small.
Smaller than your actual size, or it is bigger than your actual size, or equal to your actual size?
Ma'am, equal.
Equal to. So size is same size as that of object. That means if a 5 centimeter pen of near 15 centimeter, if you hold it in front of the mirror, will it remain 15 centimeter or will it become 20 or will it become 10? Yes. What happens? 15 centimeter. If the image, this one pen you are keeping in front of the mirror of this is 15 centimeter, will it the image will be formed which is 15 centimeter, or whether it is 10 centimeter or whether it is 20 centimeter long?
Mom, 15 centimeter.
This is 15 centimeter long. So will it be 15 centimeter long or 10 centimeter or 20 centimeter?
Mom, 15.
It remain 15. So size of the object and size of the image will be same. There is no change. So same sized image is formed. So same size image is of same size as that of object. Clear?
Yes, Mom.
Now position, where you will obtain the position. Here you can see. So here, this distance is x. The same distance will be formed behind. So image distance from the mirror is always equal to the object distance from the mirror. So distance of image from the mirror is always equal to distance of object from the mirror. Clear? Position, distance of image from mirror is always equal to distance of object from mirror. That means if suppose the object is at a 1 meter distance from the object, is 1 meter from the mirror, then image will be formed. How much distance the image will be formed?
Ma'am, 1 meter.
1 meter from
Mirror,
mirror. And how much distance it is from object?
2 meters.
2 meters. So it will, the image will be formed exactly at 1 meter from the mirror, always. Now if this object moves 20 centimeter towards the mirror, how much is the distance between the image and the object? Object is at 1 meter, image is at 1 meter now. Now if this object moves 20 centimeter in front of the mirror, now what is the distance between the object and the image?
1 meter,
160
600.
centimeter.
Is
1 meter, 600 centimeters.
160.
160 centimeter. 1 meter 60 centimeter. 160 centimeters. Now 1 meter distance is there. Now the new position will be 20 centimeter towards. That means how much is distance this now? From 1 meter 20 centimeter reduce. So this is 80 centimeter. Now image will be also at 80 centimeter. It will also come forward 20 centimeter. So that means this distance is 80 centimeter. So total distance is 80 plus 80, 160 centimeters. Right? Clear?
Yes, ma'am.
That kind of a questions we will see. And one more property is lateral displacement. Lateral displacement is seen. So what do you mean by lateral displacement? You have learned? 15 second. 15 second. What do you mean by lateral displacement? उल्टा displacement हो रहा है. English में से starting line तक. Yes. What do you mean by lateral displacement? You have learned earlier classes. In class 6, you have learned all these things. Nothing new for you. Yes, Patigret? What do you mean by lateral displacement?
The displacement of the object laterally.
Means? Laterally means? That's what I'm asking.
Horizontal.
No. What does that mean? That statement mean? What does that statement mean?
Ma'am, when we see an object from the right point, then only we can like measure something properly. Ma'am, like if you see from
Can you see mirror anywhere in your hand? If you raise your right hand, what you will see? Is that the right hand of the image? Will it be the right hand of the image?
No, ma'am.
No, then what is this?
Left,
Left. And left hand side
right.
will be right. So this conversion is called as lateral displacement. Laterally inverted, not displacement, sorry. Lateral inversion. I've written wrong. It's displacement. I was seeing the glass lab. Lateral inversion. That is, image is laterally inverted. If you see this image, you see here, this thumb is on which side of yours right now?
Right.
Right. And here, if you see from that end, it is Left. So right part will become left and left part will become right here. So this right hand side and left hand side are inverted. So that inversion is called as lateral inversion. Clear? RHS will become LHS, LHS will become RHS. RHS of object will become LHS. And LHS becomes RHS. If you see the letters, can you read the letters in the image view? In the images, can you read the letter easily? Will it be the same as the normal ones? No, they are completely inverted. So that means if you are keeping the objects like images like, suppose you place LHS in front of the mirror. Here is a mirror. How you will see this? How it will be seen? LHS you are keeping in front of it. So it will be reverted.
Upside down.
It will not upside, inverted like this. It get inverted. So it is L is written. So in front of that L will be like this. It will become like this, right? L is here right side, there it will be left side it will go. The lookalike will be completely different. They will become opposite of each other. Ambulance, you have seen the ambulance written on the ambulance vehicle. How is it? Will it be the same?
No, ma'am.
Those are that is called as lateral inversion. Ambulance vehicle, ambulance is written like this. Why it is so? Because when the rear view driver, when see in the mirror, he will see this. So he can read it immediately and will give the space for the vehicle to move, pass. So this is the mirror image of this ambulance written. Ambulance written, this is a mirror image, will be always printed on the ambulance vehicle, so that when this object will fall on the mirror, it will be look like this. And then the person, the driver, the front vehicle driver can read this easily and give the space to this vehicle so that it can move faster. Clear?
Yes, mom.
So this is called lateral inversion. So characteristics of the image formed by the mirror. One is the images are always virtual images. Image is always erect image. Size is of the same size as that of the object. Size won't change. Position, how much ever the object is in front of the mirror, the image will be same distance inside the mirror. Okay. Then the lateral and laterally inverted. It will be images laterally inverted. That means RHS of the object will become LHS. LHS will become RHS. You can see your selfie pictures. Selfie pictures are mirror images. Clear?
Yes, mom.
So that is called as, these are the 5 characteristics of the image formed by the plane mirror. Have you written it?
Yes, mom.
Everyone, have you written?
Yes.
Yes, ma'am.
Okay, fine. Then you can leave.
Thank you, mom.
Tomorrow you have a test at 11 o'clock.
Okay.
Tomorrow's maths test will be at 11.
Okay, mom. Thank you, ma'am.
Okay.
Thank you, mom.
Thank you, ma'am.
Okay.